Good afternoon, everyone. I'm here as a proxy presenter for my peer's work. I'm Xiao from Renmin University of China, and I will present this work, CPAC, Pack the Resources for General Chinese Embeddings. And this work is done by Beijing Academic of AI, also known as BAAI, at Renmin University of China and Hugging Face, and USTC and the University of Montreal. Well, text embedding is a long-standing task in natural language processing and information retrieval. By representing text with latent semantic vectors, text embedding can support various applications such as the web search, question answering, and the retrieval-augmented language modeling. The wide variety of application scenarios calls for a single unified embedding model that can handle all kinds of usage in any application scenarios. However, there's a shortage of competitive models for general Chinese embedding. What's worse, the development of general Chinese embedding is severe constrained in many aspects. There are neither well-prepared training resources nor suitable benchmarks to evaluate the generality. And then the CPAC. To address the above challenges, we present a package of resources called CPAC, which consists of the following 4 resources. The CMTab, a Chinese massive text embedding benchmark, and CMTP, massive text pairs for training the embedding models, and the flag embedding, the training recipes including pre-training and fine-tuning for the embedding model. And finally, the BJE, which is a well-known text embedding model, a family of well-trained models for universal text embedding. And we will discuss these 4 resources in detail in turn. And first, the MTAB, a benchmark for the comprehensive evaluation of the generality of Chinese embeddings. It contains a total of 35 public datasets related to the evaluation of Chinese text embeddings. There are 3 groups of evaluation tasks, including retrieval, ranking, STS, classification, pair classification, and clustering, which is shown in this figure, and which cover the main interesting aspects of Chinese embeddings, Chinese text embeddings. And then the CMTP dataset. We curate the largest dataset, CMTP, for training the general Chinese embedding. To ensure the generality of the text embedding, the paired text needs to be both large-scale and diversified. Therefore, the CMTP is collected from 2 resources, of labeled and unlabeled data. The majority of the data is based on the creation of massive unlabeled data, also known as the CMTP unlabeled, which consists of 100 million data. It is constructed from the web data in the following forms. Then, meanwhile, a small proportion is from the comprehensive integration of high-quality labeled data, also known as CMTP labeled, which consists of about 1 million data pairs. And then the training recipes, the flag embedding. The training recipe of BGE is completely released to the public along with CPAC. There are 3 main components, including the pre-training with plain text and contrastive learning with unlabeled data and multitask learning with labeled data. And finally, the model, the BJE model. In our work, we provide a comprehensive class of well-trained embedding models for the community. There are 3 available scales, including large, base, and small. The large-scale model achieves the highest general representation performance, leading the current public available models by a considerable margin, where the result is shown in this table. And the performance of model in English of our English models on MTAB we use the same recipe as the Chinese models. We also train a set of English text embedding models, including the BJE Lian, achieved the SOTA performance on the English MTAB benchmark across its 56 datasets. And BJE M3, it supports 100 languages and 3 retrieval modes, including dense, sparse, and multi-vectors. And third, the BJE ranker, it's a higher performance than the embedding model. It can use to rank the top K results of the embedding model. That's all for this work. Thanks for listening.
Yeah, thank you, and thank you to Xiao for being a proxy presenter.